Okay, we're back. Hopefully you got your compass and your ruler, your tools, not your utensils, although you could try to use a fork and a knife if you wanted to. Okay, so we're going to construct a right triangle. So the easiest way, or how I want you to start, is by just constructing or taking your straight edge and tracing a line segment somewhere on this open space right here. Okay, and then when you get that line segment, put a point on that line segment. And now you're going to take your compass and you are going to make a mark to the right and to the left of that point. And you have to make sure it intersects the actual segment. So what did I do? I basically created another segment within a segment. Except now these distances right here, this is equidistant. So in other words, I just created the midpoint right here. Okay, why did I create the midpoint? Because then I can do a perpendicular bisector, right? Or I can do a perpendicular right here by just opening this up and making my mark above, below, moving it over here, right? And then I go above, below, and then I line up my ruler. You can't see my ruler, but it's going to be faster for me to use my board ruler. So I line up my ruler. Oops, it's a little off. Sorry about that. I line up my ruler like that. I try to intersect these 3 points, or at least 2 of them. And there we go. So why did I do that? I just created a 90-degree angle. So that was a point on a segment. The first thing I did was create this little segment within a segment, and then I did the perpendicular bisector of this segment right here. So why did I do that? So I could get a 90-degree angle. Now from here, I'm just going to connect any 2 parts to make a right triangle. So here we have it, and right here I'll make it all in blue. So this is my right triangle, this blue triangle. And then it says, construct a right triangle ABC. So here's my right triangle ABC. It doesn't say where I put my A, my B, and my C, so I'm going to put my A up here, I'm going to put my B right here, and I'm going to put my C right here at the right angle. It says construct the midpoint of the hypotenuse and label it D. So 3 things there. We have to find a midpoint, so you need to know what that is, and we have to find the midpoint of the hypotenuse. So what is the midpoint of the hypotenuse? Well, remember the hypotenuse is the leg, or the side, sorry, not the leg, the side opposite the right angle. The other 2 sides are called legs. So this is the hypotenuse right here. So how do I find the midpoint? Well, I just do the perpendicular bisector of the hypotenuse, except I don't need to draw the huge segment through there. Right? So here I'm going to do my little arc on top and on bottom of the line. I'm going to put it at the other corner. I'm going to do my mark on top and on bottom. And then I'm going to line up my ruler with those 2 intersection points. Again, you can't see it, but if I were to go through there, oops, looks like that's going to be a little off. That's about where my midpoint is right there. So I lined up my rulers to go through here, and it looks like this is my midpoint. Okay, so I'm going to label this midpoint D, it says. So now measure the length of the midpoint to each vertex. So I have to measure the length of AD, the length of BD, and the length of CD. So go ahead and do that. Go ahead and measure your length of AD, BD, and CD. So push pause, measure it, record your measurements. I would measure them in millimeters or centimeters, then see what you get, and then try to fill out this theorem right here. Okay, so push pause, try this on your own. Okay, so you should have discovered that those 3 measures, and it doesn't matter what mine were, because mine's a giant meter stick, and it's going to be very different to yours, but you should have discovered that those 3 lengths, so this length here, CD, this length here, AD, and this length here, BD, these are all congruent to each other. So all of these measures should have been really, really close. And if we were more accurate in our constructions, then it would have been exact. Or if you use Geometer's Sketchpad, just followed the same thing, and you would have measured those distances, those lengths, you would have gotten all of those the exact same measure. So then the hypotenuse midpoint theorem, 5.15, says the midpoint of the hypotenuse, this is the midpoint of the hypotenuse, of a right triangle is equidistant from the three vertices. So that's what we put in, not congruent, because it says from, not to. So it is equidistant, so the same distance from each of the three vertices. So what does that mean? It means these three segments are congruent to each other. So AD is congruent to BD is congruent to CD in this specific right triangle. Okay, moving on. The right parallelogram theorem says try to fill in the blanks in the following two theorems. So maybe you want to push pause and try it on your own, see if you can figure it out. If not, you can just go through it now with me. It says if an angle of a parallelogram is a right angle, then the parallelogram is a what? So if an angle of a parallelogram, so if we draw a parallelogram, it means opposite sides are parallel to each other. If I put one right angle in there, but I know it's a parallelogram, then I know the opposite angle is a right angle. And if I know these are right angles, well, their consecutive angles have to add up to 180, so these must be right angles. So therefore, by saying there's one right angle in a parallelogram, I've guaranteed that it must be a what? There's only two choices. The two choices are either rectangle or square. Well, because it doesn't say anything about the side lengths, we don't know that it could be a square. But we do know for sure that it has to be a rectangle because it does say that one of the angles is 90 degrees. Therefore, because it's parallelogram, all four angles are 90 degrees. We don't know anything about the side lengths, so it has to be a rectangle, not necessarily a square. For the second one here, the equilateral parallelogram theorem, 5.17. If two consecutive sides of a parallelogram are congruent, then the parallelogram is a what? Okay, well, if sides are congruent, it's either a rhombus or a square. So if it's a rhombus, that means it's only focusing on the lengths of the sides. That those four sides must be congruent to each other. If we do consecutive sides, remember that's one right after the other. It's this one and this one. Those are consecutive. These two are consecutive. These two are consecutive. These two are consecutive. One right after the other. If a pair of those is congruent, then we know that it is a rhombus. Why is it not necessarily a square? Well, a square specifically has to also say something about the angles. And it doesn't say anything about an angle. Therefore, the only thing we know is that it has to be a rhombus. Okay, let's go to some more complicated constructions down here. So I gave you a length AD, and with this length of AD, we're going to construct a square, but we're going to do it two different ways. The first one is where AD is the side length. So the first thing you need to do is start with any length, and then you need to maybe put an A on there, or I'll put a D on here since it's on this side. And I'm going to go up here, open my compass to the length of AD, and then I'm going to go down here, and I'm going to mark that length. Oops, just messed that up. Okay, oh well. So now this is A. So I've just replicated this length here. So that's one side. Okay, well, yeah, we know sides have to be the same length, but specifically what needs to happen with a square, we need to have a right angle. So we are going to do the same construction we just did above, up here. Remember, and that's when I constructed this segment within a segment, so we could do the perpendicular bisector to get a 90-degree angle going through this point on the line, or on the line segment. So if I want to get a 90-degree angle going through this point, well, it'd be best, I guess I can really shorten this. So I can shorten, 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 and then I can make a mark here, and then I can swirl around to the other side and make a mark here. And now I have to perpendicularly bisect, so I'm going to go here, open my compass, open a little bit wider, right, and I'm going to do my mark on top and on bottom, and then I'm going to move it over to this side, and I'm going to do my mark on top and on bottom, and then I'm going to take my straight edge that you can't see, and I'm going to make a segment that goes through these 3 points, and that then determines a 90-degree angle. Okay, so now I have this unknown line that goes on forever and ever. So what do I have to do if I want it to be a square? Well, every single length, side length needs to be the same. So I've got to go back, and I have to measure this specific length of the square. So there we go, right? So the sides have to be the same length. So now I know that this side, right here, AD, I'll do it in purple now, is the same length as this side, and I just guaranteed that by making this up here. So these two are the same. Okay, now, to get your other two sides, you have two choices. You have the longer option, which is to construct another right angle through D, or, I think, the shorter option. What is the shorter option? Think about it. You need two intersections up here to make sure you have the other length. Okay, well, one of the intersections, or one thing you have to know for sure, is that it has to be the same length that the other one was, right? So we know it has to be from here to here, that same length, but we don't know where to draw it on this arc, right? So that's the issue. So we need another point. So what am I going to do? I'm going to do my diagonal. Look how easy this is. If I go out and measure this diagonal, what do you know about the diagonals of a square? Well, diagonals of all parallelograms are congruent to each other. Therefore, if I measure the length of the diagonal and I go over here to this corner and I swoop this up, then I get my point of intersection. I just guaranteed my diagonal length, and this length going up doesn't look very good. I'm a little off. I can tell how I'm holding my ruler is off. It's not good, but that's okay. We do our best. And then we just connect here and here. So the 90-degree angle construction is the harder one. So you just do the diagonal length, measure your diagonal, and then measure this length, right? And then you get that point of intersection to guarantee your fourth vertex of your square. So there you have it. Here's a square with all side lengths AD. Okay, let's look at the second one. The second one says, let's make AD the diagonal. Ooh, that's a little tougher. The diagonal. Okay, well, what do we know about diagonals of a square? There's two things we know. One is based on the fact that it's parallelogram. We know the diagonals are congruent. Okay, that doesn't help me much, because how do I know at what angle they're going to intersect? Oh, that's it. They bisect each other. They're perpendicular bisectors. So the diagonals are congruent, and they're perpendicular bisectors. So what's the first thing I do? Well, I'm going to make a segment. And then I'm going to open up my compass to this length. And I'm going to move it down here. I'm going to put a point. I'm going to move it over here. I'm going to mark this. Okay, so that's the length of the diagonal. So now what do I have to do? I have to perpendicularly bisect this. I don't know what happened to my purple line. That's kind of weird. Put it back there. Okay. So I have to perpendicularly bisect this segment. Okay, so let's see. What do I do? I'm going to do my little swoop. I'm going to go over here. I'm going to do my little swoop. And then I'm going to construct oops, a little off there. Okay, so right now I have my original AD was right here. So this is A, this is D. And then I did a perpendicular bisector because we know that the diagonals of a square intersect each other perpendicularly. Now I have to take my compass and I have to measure this distance right here. Right? And then I basically have to go up and mark it here. So what am I making? I'm going around and making a circle, essentially. And then there we have it. You connect these points And we are done. Next video. See you soon. Talk to you soon.